In today's video, I'm going to show you how we can code a decentralized app like Rarity Tools. Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome to the channel where I teach you how to code. Now, in today's video, like I explained, we are going to be creating a website like Rarity Tools. And it's really cool because Rarity Tools is a website that allows artists to put up their upcoming NFT collections. Firstly, it's a great tool to go and have a look at when up-and-coming NFT artists are dropping their collections. But how can we take this concept and create something similar but decentralized using a smart contract that we will be creating on Remix? This is very exciting because not only are we going to be writing a smart contract for the backend for our website, we will also be looking at styling. And how can we style a React application with CSS looking something like this? We won't go for the exact same styling because we want something different. But the whole concept that we are going to create is a finished product. I am very excited to start this journey with you guys from A to Z. Now, please be aware that my channel is here for educational purposes only. Everything I do on this channel is not intended for you to go ahead and put it on production. Please review the code first before you do anything or use the code, and use it at your own risk. Lastly, I'm not a financial advisor, so don't take any of my financial advice. But that being said, let's get started and let me show you the whole process, and let's dive into the code. Before I start any project, I usually like to take a look at what I'm going to build, sketch it out, and plan it out perfectly. In this case, we already have this kind of example in front of us that we want to build. In our case, we already have this in front of us to have a look at. So you can see that it's basically a list of drops that's going to happen or already happening, so to speak, where people can go and mint. For example, we can see on the left hand side there's some cool images of the collection, some information on the socials, and then information about the drop, especially the price, total supply, and when the drop is going to happen. While we are here, let me give a shout out to the door community, the Desperate Ape Wives. It's such a cool collection and I even own some myself. Anyway, let's get back to the tutorial. So basically it comes down to displaying a list of collections. Now we probably need some place to upload our collections, and I see they have a button where you can do that on list your project, and then it gives you an option to pay to Ether to have a featured listing. And then we simply have a form where you can fill in your email, project name, basically information about the project itself. We can refer back to this when we actually develop the application, so we're not going to look at this in detail right now. What we are going to do is jump over to Remix to start coding our smart contract. What you want to do is go to remix.ethereum.org. This is Remix, a Solidity online compiler that we can easily use to write Solidity code, compile it, and even deploy to the blockchain. So it's pretty cool. What you can do is, once you're on Solidity's compiler, the Remix compiler, we can click on this plus icon and create a new workspace. Remix will now give you a brand new project with 3 default files: storage, owner, and ballot. These files are pretty cool and you can read through them, but we want to create a new smart contract. For now, maybe we should call this NFT drop hunter. I'm not sure if this is a name that's already taken, so maybe I'll just add the HashLips in front of it. So NFT drop HashLips hunter.sol. That's a very long name, but it will work. Now that we have our NFT drop HashLips hunter.sol file, we need to specify the license. Now I'm going to click on ballot.sol for a second and grab the license over there. Then I'm going to paste it there right at the top. This is just specifying what type of license this contract is going to hold. Usually it will be something like this or MIT. There's a lot of licenses and you can read up on it. Next, we need to specify a pragma line. A pragma line is there to specify to the compiler what Solidity version is going to be used to compile this code into the bytecode. Okay, so let's specify the pragma line. So you're going to write pragma, Solidity, and then specify the version that you want the compiler to use when compiling your code. I'm going to choose anything upwards of 0.8.0. That's kind of a recent version of Solidity, and it's a good one to use, so I'm going to use that. Let's define our contract by writing contract, specify and give the contract a name. I'm going to call it HashLips Hunter, and then open and close your curly braces. This is the basis of the contract. And now it's time for pseudocode so that we can actually see the flow and what we need to do in the contract, and then we'll add the functionality. What you see before you here is the pseudo list I came up with for functionality that we need to add to our program. We're going to go through this list and one by one add the functionality. Pseudocode is there for us, or pseudo definitions, if I can put it like that, is there for us to help facilitate and preempt what we need to do when coding. And that's why it's a good practice to sometimes write out what you need to do. So firstly, let's define our object that we are going to be using. So let's imagine we go to this website and people actually go and add their project. We will need something that can contain the data of the image, well actually just the URL, so a name, a description, some info on the socials and all of this. A perfect data structure to use for this is a struct. And how you start off defining a struct is by placing the struct keyword. A struct is a nice data structure that you can define to create your own data structures. So for instance, we can call this the drop. And you can just specify your curly braces like so. And now we can define the fields of our drop. Now in general, saving strings on the blockchain is quite gas intensive. So we are going to try and keep it to a minimum as far as we can. But we are going to have to save the name, the description, as well as the actual URI where the image lives. So we can't go around that if we want to do it all on chain, but let's go ahead and define it. So we'll start off by defining a string like so, and let's call it the image URI. And we're just going to do that. Then we need a new one which would also be a string, and let's give it the name and string description. By looking at it now, we are actually going to have a lot of strings, but that's okay because we are going to do this on the Polygon blockchain. Although this contract can technically be used on Ethereum as well, I think for Ethereum the gas fees will be a lot. So let's carry on and let's just get the concept down. We're going to need another string for socials. So instead of specifying maybe Twitter and Discord, let's keep it to maybe social 1. I don't know, social 1. And then string for social 2. We are going to need a website as well as a price. And then we need the total amount of NFTs. So this we can make UN 256 and we can call it the supply. And the reason why it's UN 256 is because that's a big data type. So if someone had thousands of NFTs or millions, they can still specify that easily. But you can see we are starting to use integers now, or unsigned integers, because we have a lot of strings. The reason why price is also a string is because we can't rely on the weigh amount. Well, we technically can, but we'll work it out. For now, let's just leave that as a string as well. We will need another integer for basically the timestamp for a pre-sale. So let's do the pre-sale, and then another unsigned integer for this sale. I'm doing this because if we look at some of these drops, some of them have a pre-sale and some a sale. So we're going to base this on timestamps and kind of convert it to what we need on the blockchain and convert it back to our local time. Let's just make sure that we have everything. I can see that we still need another integer, and this time I'm going to make it a uint8 because we only need a small space from 0 to 255, and that is for our chain. Now we're going to assume that 0 would be, or 1 Ethereum to Solana, so that we can work with it on the front. We're also going to need the very last variable, and very important, is an access or content control basically variable, and we're going to call it approved. And the reason why this is there is so that admins can approve the content after it's been suggested to be published, or if there was an update. We always need to have an admin approve this content before it can be shown to the public. Okay, great. So now we have our drop object, and what we need to do next is create a list that contains the drop object. So we can create an array. So we can specify that this is going to be an array of type drop. We're going to make it public as well as give it a name. And I'm going to call it maybe the drops, like so. Now we got our drops list, and we need a function to kind of populate them so that we can test this out. Let's go and create a function that can add drops that people specify to our list. For those of you who are new, by the way, these gray looking sentences are called comments, and they simply don't do anything to the code base. I just want to mention that for if you wanted to know. I'm going to skip the get for now and just focus on adding. So we're going to create a function. You can specify a function by calling the function keyword, and then let's give it a name. So I'm going to call this add drop. And then our function is going to take in a few parameters, but for now we're just going to end it with our curly braces, make it public as well, like so. Later on, we are going to specify access control, but for now it's not important. We just want to add our drop so that we can retrieve it and test this out here in Remix. So let's specify the parameters that this function will take. So the purpose of our add drop function is to add a drop that looks like this to our drops list. Let's go ahead and do that. So our drop would probably need to take in all these arguments for it to create a new drop. Now let's go ahead and specify that we will basically create this drop. So I'm going to make this of type drop in the arguments. So let's say this is going to be taking in arguments a whole drop object, and we are going to specify this as memory data allocation to tell the compiler that this is temporary data. Now that we are ready, we can go ahead and populate or create a new drop to populate the list. Now let's use this underscore drop that's going to be sent by a user to us. Remember, we want the approved to be false by default. So if someone set it to true by adding it to the add drop function, we want to set it to false again. That's why we are going to first create a new drop object. We're going to give the data type of drop, specifying that this is going to be an object of type drop. We're going to assign the memory allocation as well. And then we're going to say this is going to be our new drop. This is the name. And this is going to be equal to the underscore drop over here. Now all that's left to do is to say new drop dot approved, because we want to change the instance that we have here of approved, because drop might come in here and people might have said yes, this is approved, and we need to set it to false by default. So we're going to set this equal to false, like so. Then we can take this drop list and push to it. Pushing to an array simply means adding to it, appending to the array. So you will specify drops.push, like so. And then inside here, we are now going to drop our new drop. And that is it. This should now enable us to add drops to our list. This looks great and we can test it out. We can head over to the deploy and transaction section, deploy it, and there's our contract with our add drop function and our drop array. We can now see that this add drop takes a tuple, which means it takes basically a list of values that should be in the order of this. I do like using this, but it's really not clear and sometimes you make a lot of mistakes not providing the correct information. That's why I prefer if we redo this a little bit differently. I'm quickly going to make the changes just to show you a better way where you can read the data better that you supply to your contract. So the changes that we are going to make is basically going to copy all the information we need. Then we're going to put it in here like so. This might seem redundant and a bit silly, adding more code, but trust me, it is more readable at the end of the day. So let's go ahead and change this up. We need to make this type of memory, and I'm going to add an underscore to all my variable names, like so. Let me quickly do this, and then I'll show you why it's better to describe all your arguments in this fashion. Now that my strings have memory data allocations, as well as all the variables in my arguments have underscores, I just need to add all the commas because it needs to use this structure when passing in variables. So I'm just going to change that, and you'll see that yes, this is a little bit more code, but at the end of the day, it's way better to understand what you're doing when you're doing it explicitly like this. You can see that now we don't have a new drop object anymore, or an underscore drop object, and we need to instantiate a new drop. So seeing that we don't have this object anymore, let's get rid of it. We still need to create our drop, but we don't have to do it like this. We can simply do it all in one. Let me show you. I'm going to remove those two lines, keep my drop.push, and then in here specify that I want a new drop object, and then I need to pass in these variables in the same order. So in the brackets of the drop, I'm going to give myself some more space, and then basically start from top to bottom, starting with the underscore image, followed by a comma, then the name, then a comma, then the description, comma, and I think you get the picture. So now it's going to be the social 1, then it's going to be the social 2, we've got the website, we've got the price, and this is quite a big object. Like I said, there is a little bit of a better way of doing this, but this is the most explanatory way for me to show you how you can work with structs. So we already have the price, we need the pre-sale, we need the sale, and then we need the chain as well. Now, we do not have the approved. So for that variable, I'm going to add one last comma and make it false. That by default will give us the whole object. Let's not forget the comma over there. Now when I save it, I can see that it is a little bit more code, as you can see, but wait for it. Let's redeploy this contract and you'll see why it's better. Over here on the left hand side, I'm going to close down this contract and redeploy it. Now you can see when we see our add drop function and we extend it, we can see all the variables it will need for us to create a successful drop. So this is what we need, this is what I want, and I think it's way better to explain it like this, and functionality wise we can see what fields it would need. Let's now go ahead and add one drop. I'm just going to briefly type out a few things. So I'm going to add HTTPS, and I think I'm going to skip through this so you don't have to sit through me adding all the variables. Okay, now that I've filled in all the fields, let's quickly run through them. I filled in the image URI, the name, description, my two social media handles, quote unquote, and then we have the website, the price, the supply, pre-sale, sale, and the chain, which is only one because we're going to say one is Ethereum and 2 is maybe Solana. Now that we have this, we're going to say transact. And boom, there we go. We can now see that it was successful. So if we query our drop in index and place an index of 0, and we query it, we get all the information back. We can add another one and maybe make the price 1 and call the new collection, let's call this Rush Rooms, like so. I'm going to transact again, and yet another one was successful. So if we query now index 1, we can see that the drop is this one. Yet this hasn't been approved, so we need to still create that function for the owner to approve it before it will be displayed on the website. But this is exactly what our website will do. We will query the array, and then we will go and find the image, and we'll display all this data to the users. Now let's define a function that we can call to get the whole array returned back instead of just returning indexes. So we can define a function over here and say get drops. Then let's make this public, and this is probably going to be view because we are interacting with data on the blockchain. And then we're going to say this returns to us a drop array. Perfect. We need to say this is going to be of type memory and do that. Then all we're going to do is say return to us the drops array, like so. When we call this, now we will get all the drops associated inside this list. And that's exactly what we want. We also need a method to update a drop. Let's say a person got the image URI wrong and they want to update it. We're again going to kind of have the same function like this, but this time calling it update, and we need to set the this approved variable to false again for us to reapprove what they have updated. Let's go and create our update method. We can just as much copy everything here for the add drop. And then let's go and see. We don't have an update function here, so I'm just going to paste it right below it and call this update. Like so. I'm not only going to pass in all the parameters, but in the very beginning I am going to specify a uint, and this is going to be the index, like so. But I'm going to call it underscore index. And there we go. This time we don't want to push onto this collection. So instead, what we're going to do is cut this out, this drop, just for now. And then we're going to say alter the drop, and on ID or index, whatever we pass it, should be equal to this. Perfect. Our update method is complete and it will do the job, but it's not correct because anyone will be able to edit any drop, and we only want the owner of that drop to be able to edit it. We'll get to the security part in just a second. Let's go and complete what we need to do in order for this to work. We need to approve this drop somehow. That's going to be very easy. What we're going to do is create a new function, and let's call it approve drop. And this will only be called by the owner, so we still need to do that part. But let's call it approve drop. And then what we need to do is make this view. This is not going to return anything, but it is going to take in the parameters a uint 256, which is going to be the index. And all we need to do is we need to basically go and set this drop to true. How can we do that? This time we're going to use storage data. So let's define a drop of type drop, and we are going to say this is storage. What's the difference between storage and memory? Well, memory is temporary and it doesn't affect the current data in the storage, whereas storage will affect the actual object that we are working with if we pull it out. Let me show you what I mean. We are going to set the storage of this drop equal to the drops wherever we query the index. So now that we have queried where this location is, and this is now saved into storage, we can technically go and change it like that. We also don't have to save it first. We can technically just update it. but I just wanted to show this so that it's very clear. So currently we can say that this drop.approved, like so, should be equal to true. And that is it. Now that I think of it, there would really never be a reason for us to clear the data. And the reason for that is, if we don't want to display data older than a certain date, we can give it a certain time period and not display it on the front. And that being said, if we want to deploy a new contract, we can do so. So let's keep it simple for now. I'm not going to have the removes, I'll only have the approve. Like I said, we still need to cover the use case for an owner to only be able to update their drop. So now we need to create a mapping of an owner and a ID relationship. Let's go and do that. So in order to keep track of which users own what drops, we can do a simple thing using a mapping. We can specify a mapping right here underneath our drop array, and let's make it a mapping of UN256 to addresses, like so. We can give it a name and let's call it user, the user mapping. That's perfect. Let's now go ahead and make the users plural actually, and make it public so we can test it. Then, where we create a drop on this function add drop, we want to create an extra variable and actually assign this drop's ID, aka the index, to an address. So how can we do that? Well, let's specify a new integer value, call it ID, and this is going to be equal to the drops.length. So, like so. And then we need to remember to minus it by 1. We can also wait for the push to return an ID, but I'm going to do it like this. Then right after this, we can now assign this to the mapping. Let's access our users mapping, specify that at the position ID, which should now be an integer, we are going to equal this to the message.sender, like so. That way, we know, and we can close this up, we know that we are basically going to assign a user who created this drop, and only this user should be able to update it. In order to block anyone from updating this drop if it does not belong to them, is simply adding a require statement. We are going to require that the message.sender has to be equal to the users whose index this belongs to. So that's why we're going to pass the index. This will return to us an address. And if this is indeed the user that was added here when this drop was created, then only they can update this drop. We can also leave a message and say, you are not the owner of this drop, like so. So the last thing that's left for us to do is basically specify an owner. So right here at the top, let's just specify a new address type and let's call it our owner. And this we're also going to make public, like so. Now the owner is not defined yet, and we can define that in a constructor function. So right below here, let's create a constructor function. A constructor function basically only runs once and only once, and that is when you deploy the contract. That is good news for us because it means that right here we can set the owner equal to the message.sender, meaning that the sender or the deployer of this contract will from now on be the owner. Now we're not done yet. We need to also create a modifier. So a modifier is something that we can add on top of a function for code to execute only under certain conditions. So for instance, we can now create an only owner, like so, modifier, and then you specify it like this. We're going to add a require statement and specify that the message, like so, dot sender should be equal to the owner. If not, we can say you are not the owner, like so. And then how modifiers work is you specify an underscore with a semicolon. By specifying that, you're telling this modifier that if this condition is true, then only render the code that's in the whole function. So now we can go ahead and down here, add it to our function where we get to approve the drop. So only the owner is allowed to do this. We are basically done with the functionality, but we can see there's one error, and that has to do with the amount of variables that we're passing, particularly inside the update drop. This is kind of maxing out what Solidity is comfortable handling and can handle. So a solution around this is by passing in a struct. Now in the beginning we had it set up like that, but I took it away for demonstration purposes. This time I'm going to put it back so that now that you've seen how it basically works, we can pass in a drop object and call it memory and call it the drop. Now we can go here and push this drop onto our array. So with a small change, we can see that the function is a lot less intensive as well. Before we add this drop, we need to make sure that the approved is always false. So let's go and set the drops approved variable equal to false. And then we push it, we get the ID, and we assign the message.sender as the user. Now we can do the same for this, but this time we have an ID as well. So I only want to take out this. Then we're going to specify our drop. It's going to be of type memory. And again, we're going to do it like this. This time, we can do exactly the same. So I'm going to take away this drop and basically put it equal to this drop. Before we do that again, we need to make sure that the drop's approval is set to false, like so. This minimizes the code tremendously. But now our error is gone and we can see that this will indeed compile. And now that you understand the basic concept of how we work with structs and how we can update variables, let's give it a go and let's give it a test. So we need to deploy this in order to test it, and you'll see that here right at the top where it says drop, I have actually commented out the values that we need to pass, because this time we need to pass it as a tuple. Now what we're going to do is uncomment this. You're probably going to have to type this out just like it is. These are just test values, but go ahead and try it out if you want to test with me. Now I'll pause the video, or you can pause it, and then we'll continue. Let's go ahead and deploy. Before I do, I'm going to select everything and copy this. Then I'm going to comment it all out. You can do this on the Mac by selecting everything and pressing Command /. Otherwise, you can just simply add // to each one of these. You don't have to keep this in your contract, but I'm going to do that because we are going to test with it quite a lot. So next thing is go to the deploy and run transaction, and then go and select your contract down there and hit deploy. Now we can see to add a drop, it takes one value, which is a tuple of type drop, basically an object. So all we have to do is put our square brackets. So you put your square brackets there, and in the middle, paste all those values. Now I'm going to hit add to drop. And boom, it was successful. So now when we query this drop, we can see on drop 0, if we call it, there it is. I am now also going to test all the other functionality of my smart contract. So firstly, what I would like to test is if we can update this contract. Let's say our supply shouldn't have been 22, but we wanted to make it 1,000. Let's go here and see what we need to paste in. We need to give it an index, which we know sits at 0, and then we need to give it that tuple again with all the values. This time, I have to go and update one of the values. So let me go and update 22 to 1,000. I'm going to hit transact, and there we go. It was successful. So now if we query this again, it should have been updated. And there we go. Now it's 1,000. But we should not be able to update it if we're not the owner of that drop. So let's switch to another user and try and update this again. This fails and it says you are not the owner of this drop. This is perfect. We also have to test if this person will be able to update or basically update and approve this drop. This function is specifically just for the owner. But let's see what will happen if we try and update if we're not the owner. A collection to approved. And there we go. You are not the owner. And it fails, which is expected basically. So let's go and switch our account back to the owner. Let's go and approve this drop. It was successful. And if we go down here, if we query this again, this Boolean down here should be true. So we query it, and indeed it is. This we can use in our front end to now display this to the whole world. So next step is to actually deploy this contract to a network. We are happy with the contract and we are going to deploy it. Now, before I deploy any contract, there's obviously a few checks that you do. You make sure that your values are perfect and that you are happy with your contract. Please review your code thoroughly before deploying it to the blockchain. We will just be deploying it to the test Ethereum network. By the way, we can also do this exactly the same on Polygon, which is probably better seeing that we need to interact with the contract the whole time. I'm just going to use the Rinkeby test network for Ethereum because I've got some test Ether in there. But you can do this on Polygon or whatever network you want to. Before we deploy, let's make sure that we enable optimization. That's just a personal favorite of mine. And then I'm going to go to the run transaction to deploy our contract. Next, here on environment, I'm going to select injected Web3, which will then in turn select Rinkeby network 4. Now, Rinkeby is the test network. Like I say, I've got some test Ether in here, 2.3 Ether on the Rinkeby test network. So obviously, if you switch this to the live main network, whether it's Polygon or Binance, whatever it is, Remix is going to try and deploy it to that network. So be careful with this. I'm on the Rinkeby network, so I know this is just for testing. After that, make sure you're on the right contract over there, and then I'm going to hit deploy. Perfect. Now I can just confirm this. Our transaction was successful, and you can see it over here. You can also see that it was successful by going to your MetaMask and looking at the contract deployment over there. If we click on this, we can even go to the Etherscan test network to go and verify our contract, and there you can see it. Here is our new contract address, which you can copy, or you can go back to Remix. If it's down here for you as well, you can simply copy the address there, then go to test Etherscan. Remember, this is the Rinkeby test network. So just be on the right Explorer and then paste that in there and click on search. Here we go. The contract was successfully deployed and now we're ready to rock. The next step for us would actually be to interact with this contract. We need to interact with this contract basically through a Dapp, and that's what we are going to create from scratch. But before we go, we need to verify this contract. You can see if we click here, it still says verify and publish. Let's quickly do that so we know that we are finished with the deployment part. In order to verify, click on verify and publish. Now we are quite lucky because we didn't have constructor arguments, meaning that this will be very smooth. So what we can do is go and select a compiler. So this is a single file, the file type. Then the compiler that we were using was 0.8.7. And then the license, I believe, was MIT. Now we can say continue. If you want to verify all those details, you can go back to Remix and then go and check here on the compiler what the compiler was, and there's your license, just to be sure. Now in the next part, in the next phase of the contract verification, you'll see it's going to ask if it was optimized, and yes, because we selected yes, right? Then it's going to ask you to paste all the code in here. So we're going to go back to Remix, copy everything in here, go back and paste it. Seeing that we had no constructor arguments over here, we don't have to enter anything. We can simply say that we are not a robot and that we can verify. Now I'm going to do this, but a lot of people get stuck here. So I'm just going to show you what to do and what to enter there because it is quite confusing. So let me just go ahead and just jump back to Remix and show you what happens if you have constructor arguments. Let's say that in my constructor, I had to pass in a string. So I'm going to say this is string memory and this was my name. And then up here, maybe I had a string and this was my name. And then when I passed it into the constructor, I basically set name to equal to the name. Well, let's just give it a different variable like so. All right, let's say that was my constructor argument name. Now, if I were to deploy this contract, in the deploy section, it's going to ask me to fill in a name. So if I filled in Daniel, I had to copy this argument list. Doesn't matter how big it is, you need to copy the ABI encoded data. So copy this, then go to any text file, and let me just create a new one, test.txt. We're gonna paste it, I'm gonna save it, and then usually when you go back and click on that file again, it should open up like this. Then you take everything from the bottom upwards. Now, depending on how many arguments you had, the list will be longer and the zeros, the trailing zeros, will be longer as well. So what do I mean by trailing zeros? Well, you can see there's a bunch of characters in here, but you can definitely see that at some point, a lot of zeros starts trailing, and then a 2, and then more zeros, and then this little bit over here. Now, that ABI encoded data is everything from that start of the trailing zero over there all the way down. So if you had some constructor arguments, you copy it like I've shown you, and you copy everything from the trailing zeros. That's it. Once you've copied it, you can go and paste it over there on Etherscan. And then you should succeed. So we don't have that. So like I said, I'm just going to say I'm not a robot, click on verify and verify my contract. This doesn't take long. And if everything was successful, it should just work. Nice. This was successful and our contract is now verified at this address. So we can now go there, click on contract, view the contract, as well as interact by reading some of the data on it, as well as writing to it. We are definitely going to do that in this series. But now you have a nice way of interacting with your contract on Etherscan. Now, a question that I have is a lot of people don't like interacting with their contract here. They prefer doing it on Remix. But let's say here is the contract that was deployed and I'm going to remove this. What happens? How do I get this contract back? Now, obviously you have Etherscan to interact with your contract. You can read and you can write to it. So there's no real need to use Remix, only for preference sake. So basically how you can rectify that, if you want to use Remix again, is you copy your contract address, go back to Remix, make sure you have the exact same contract selected. It needs to be exactly the same. Then over here, instead of deploying the contract, a brand new contract, you can simply enter it at the address. When you do so and you click on it, it doesn't deploy, but it simply references the existing contract like on the blockchain. And that is a simple trick that not a lot of people know, but now you do. That being said, I still prefer Etherscan when interacting with contracts. Now, this is not the ultimate development setup. Like I said, there's many more like using Truffle, Hard Hat, and all those things. But as a beginner, using Remix and then interacting on Etherscan, we are now going to build a Dapp using React. And I'm very excited to show you guys that. That is going to happen in the next part of this video, which will come out right after this one. But in the meantime, if you are getting stuck and you need some help, go to our website hashlips.online/hashlips, and then you can click on Discord or any of the other social media channels. Discord has a lot of devs and community members that's willing to help. Lastly, I want to say thank you to the 17,000 subscribers. Without you guys, this channel and my tutorials will not be even worth it. I really appreciate each and every one of you, and if you are now a part of the HashLips family, welcome. If you haven't subscribed yet, go ahead and do so that you don't miss out. Also remember to give this video a thumbs up and comment, because I do read them. Maybe comment what you would like to see me do next, and I will definitely follow your advice and maybe make that video. Till next time guys, or till this next video where we're going to create the Dapp, have a nice day, and I'll see you in the next video.